How's it going, guys? In this video, we're going to be going over Module 8.2, Day 3. And the very first thing you should see in your notes or in your packet should be a warm-up. So if you haven't tried it yet, go ahead and pause the video and try it. We're only going to worry about the total number of roots. I know, at least in the in-person packet, there is another part of it asking you guys to put these into a calculator and see the real and non-real zeros. We're not going to worry about that. So for now, just go ahead and tell me the total number of roots. Okay, and so the total number of roots of this polynomial will just be 5. The total number of zeros or roots in a polynomial will be equal to the degree of the whole polynomial. And this polynomial, the degree is 5, so the total number of roots or zeros will also be 5. So let's go ahead and get started with the notes. Today we're going to be talking about determining the real and non-real zeros for the graph. And when it comes to a graph, we can actually figure out exactly what our real zeros of a polynomial function will be from the graph. Our real zeros, our x-intercepts, and our real roots in solutions, all of those can be used interchangeably. Your real zeros, your real x-intercepts, and your real zeros and roots, and your real solutions. Those are all used interchangeably. All right, but the one thing is a graph will not tell you what your non-real or imaginary zeros are. A graph does not have any plots or any numbers for the imaginary numbers. We only look at the real numbers when we're graphing something on a grid or something. We only look at the real numbers. All right, so we can figure out exactly how many non-real zeros we'll have, because remember, the total number of zeros of a polynomial will equal the total number of real roots plus the total number of imaginary roots. All right, and that's exactly what we're going to be doing today. So in this first graph we have over here, f of x equals x to the 4th minus 2x squared minus 3. The graph intersects the x-intercept 2 times, right here and right here. All right, so that tells me the function is going to have 2 real zeros, because the real zeros and x-intercepts are the same exact thing. But because of the corollary to the fundamental theorem of algebra, that tells us, the corollary tells us that this function has to have 4 total zeros. The degree of the whole function is 4, so that means we have to have 4 total zeros. So if we're supposed to have 4 total zeros and we have 2 real zeros, that must mean we have 2 non-real zeros, right? The total number of real zeros plus the total number of non-real zeros has to equal the total amount of zeros. So in this case, 2 plus 2 equals 4. So let's go on to the second graph. In this one, we have f of x equals 3x squared plus x plus 24. Or in other words, the degree of this polynomial here is 2. So we see that the graph never actually intersects the x-axis, so we intersect it 0 times. And if the graph intersects the x-axis 0 times, that tells me the function has no real roots. Okay? So if I have no real roots, and the whole degree of the whole function has to be 2, so I have to have 2 total roots, that must mean there's going to be 2 non-real roots. I have to have 2 total roots because the degree of the polynomial is 2. I have 0 real roots because I never intersect the x-axis, so that means I have 2 non-real roots. And last, we have a 5th degree polynomial over here. And if we're looking at the graph, we can see that we intersect the x-axis only 1 time, right here. And so if I only intersect the x-axis 1 time, the function has 1 real root. But according to the corollary of the fundamental theorem of algebra, if we're a 5th degree polynomial, we have to have 5 total roots. Okay? And if I have 5 total roots and I have 1 real root only, that means I have to have 4 non-real roots, because the total number of non-real roots added with the total number of real roots has to equal the total number of roots. In this case, 1 plus 4 has to equal 5. Okay? That's pretty much it for the notes, guys. In the packet, in person, we do have these homework assignments. Don't worry about them. I don't really like them. We're not going to do them. But instead, if you want practice going over the notes that we have today, because that will be on the test. The notes section anyway, not the homework. The notes will be on the test. There are a few problems in the review packet that you can find online or in the back end of your packet that will go over what we went over in this video, guys. All right. So hopefully this helps, and that's it.